Welcome to the third section, Writing a Reddit Reader with RxPHP. In this section, we will start with examining RxPHP internals. Then, we'll move to create and defer observable. After that, we will be writing a Reddit reader using RxPHP. Then, we'll see non-blocking CURL observable. Lastly, we look at types of disposable classes. Now, we move on to the first video of this section that deals with examining RxPHP internals. In this video, we're going to take a closer look at subscribing to observables and operator chains. Disposables are a means for releasing resources used by observers, observables, subjects, and so on. In practice, a disposable is returned, for example, when subscribing to an observable. We take a code from the default RxObservable subscribe method. This method first adds the observer to the array of all subscribed observers. It then marks the observable as started. At the end, it returns a new instance of the callback disposable class. This class takes a closure as an argument and invokes it when it's disposed. This is probably the most common use case for disposables. This disposable just removes the observer from the array, and therefore it receives no more values emitted from this observable. Let's take a closer look at subscribing to observables. It should be obvious that observables need to work in such a way that all their subscribed observers can be iterated. Then, unsubscribing via disposable will need to remove one particular observer from the array of all subscribed observers. However, if we have a look at how most of the default observables work, we find out that they always override the observable subscribe method and usually completely omit the part where it should hold an array of subscribers. Instead, they just emit all available values to the subscribed observer and finish with the onComplete signal immediately after that. This highlighted lines of code are actually source code of the subscribe method of the RxReturnObservable class in RxPHP1. The ReturnObservable class takes a single value in its constructor and emits this value to every observer as they subscribe. Let's understand how the life cycle of an observable might look. When an observer subscribes, it checks whether a scheduler was also passed as an argument. Usually it's not, so it creates an instance of immediate scheduler. In RxPHP2, the scheduler can be set only in the class constructor. Then, an instance of composite disposable is created, which is going to keep an array of all disposables used by this method. When calling composite disposable dispose function, it iterates all disposables it contains and calls their respective dispose methods. Right after that, we start populating our composite disposable with this line of code. This is something we will see very often. The schedule interface in schedule function method returns a disposable interface, which is responsible for canceling the action and releasing resources. In this case, when we're using immediate scheduler, which has no other logic, it just evaluates the closure immediately. Since immediate scheduler schedule doesn't need to release any resources, it just returns an instance of RxDisposable empty disposable that does literally nothing. Then the disposable is returned and could be used to unsubscribe from this observable. However, as we saw in the source code, this observable doesn't let you unsubscribe. And if we think about it, it doesn't even make sense because ReturnObservable class's value is emitted immediately on subscription. The same applies to other similar observables, such as IteratorObservable, RangeObservable, or ArrayObservable. These just contain recursive calls with schedulers, but the principle is the same. All the code does could be stripped into these three lines of code. Well, for ReturnObservable, this might be true, but in real applications, we very rarely use any of these primitive observables. We have seen how to use RangeObservable already. Now, when we know why using scheduler in schedule function is important, we can think about how we could implement RangeObservable observables functionality. This highlighted part are our entire code. Let's run the code. We can see that it produces correct range, that is 1, 2, 3, 4, 5. However, the original RangeObservable has one interesting feature that it is able to unsubscribe inside the loop, which means that we can stop generating values anytime we want. We have another example for range. This highlighted part is our entire code in which we unsubscribe inside the observer's callable. this line of code omits only the first 3 values and then unsubscribe using dispose function. Now, let's run the code and we get only the first 3 numbers. If we try the same with our CustomRangeObservable we just created, we will see that it doesn't unsubscribe, and we always receive all values. To deal with such use cases, Scheduler has a schedule recursive method that behaves just like schedule function, but it is callable, takes one argument, which is a callable itself, to reschedule another emission. Now we see another code. We have CustomRangeObservable subscribe method to use schedule recursive function instead of schedule function. We see that we're not creating any loops ourselves, and we let reschedule function recursively call itself. Now, we can properly call dispose function on the disposable object returned from this line of code to stop scheduling more actions. This highlighted code will test the same scenario as we used with RangeObservables. Let's run the code. So here's our output, and it prints only the first 3 numbers. We're going to introduce a new type of observable called ConnectableObservable. In this highlighted code snippet, we have a simple operator chain with 2 subscribers. The ConnectableObservable class is a special type of observable that behaves similarly to the subject. Any other observable emits all available values right after you subscribe to it. However, ConnectableObservable takes another observable as an argument and lets you subscribe observers to it without emitting anything. When you call ConnectableObservable connect, it subscribes to the source observables, and all values go one by one to all subscribers. Internally, it contains an instance of the subject class, and when we called the subscribe method, it just subscribed each observer to its internal subject. Then we called the connect method. It subscribed the internal subject to the source observable. In the filtered OBS variable, we keep a reference to the observable returned from filter operator, which is an instance of anonymous observable where on the next few lines we subscribe both observers. Run the code. As we can see, all values went through both observers in the order they were emitted. This highlighted part is another code snippet. Just out of curiosity, we can also have a look at what would happen if we didn't use ConnectableObservable and used just RangeObservable instead. Here, you can see we are using RangeObservables. To run the code, we type this command. RangeObservable emitted all values to the first observer, and then again all values to the second observer. We can see that the source observable had to generate all the values twice, which is inefficient. And with a large dataset, this might cause a performance bottleneck. This highlighted code is same as ConnectableObservable 1, and we modified the filter call so it prints all the values that go through it. Now we run the code and see the output. Well, this is unexpected. Each value is printed twice, even though we're using ConnectableObservable. This doesn't always mean that the observable has to generate all the values twice. However, it's not obvious at first sight what happened, but the problem is that we subscribe to the observable at the end of the operator chain. Filtered observable is an instance of anonymous observable that holds many nested closures. By calling the subscribe method, it runs a closure that's created by its predecessor, and so on. This leads to the fact that every call to subscribe function has to invoke the entire chain. While this might not be an issue in many use cases, there are situations where we might want to do a special operation inside one of the filters. This diagram describes the operator chain where each subscription is represented by an arrow. The most important consequence of all this is that neither operators nor anonymous observable class share values that go through them. In fact, none of them keep track of subscribed observers either. Also, calls to the subscribe method might be out of our control, performed by another developer who wanted to use an observable we created for them. It is good to know that such a situation might occur and could lead to unwanted behavior. So, let us figure out how to fix this. This highlighted part is our entire code. One way could be restructuring our code. In this code, we turn filtered observable into connectable observable and not RangeObservable directly. When we run this code, we can see the filter function operator is called just once for each value. Type this command to run the code. We have successfully obtained the output. To better understand what is different to the previous example, we can have a look at a diagram representing this operator chain. We can see that the ConnectableObservable was moved down the chain and it subscribes to the filter function operator instead of RangeObservable. Using subject instead of ConnectableObservable, this highlighted part is our entire code. We said that we don't want to subscribe at the end of the chain multiple times, so we can create an instance of subject class where we'll subscribe both observers, and the subject class itself will subscribe to the filtered observable. Run the script. We see that it returns exactly the same output. This might look like an edge case, but soon we'll see that this issue left unhandled could lead to some very unpredictable behavior. We bring out both these issues when we start writing our Reddit reader.